Hello, in this video we'll be discussing operator precedence parsing problem from April 19 of a compiler construction. That's the question 3a that says consider the following operator grammar. S goes to S plus S, S star S and D. Construct the operator precedence relation table and consider the precedence function table. So first step is to find leading and trailing. When you find a leading and trailing for S, it's plus, star and D. So leading and trailing for this grammar will be same, plus, star, D. Having leading and trailing same is not a problem. But the problem is when you construct the precedence relation table, we are getting here that this plus is giving precedence to trailing of S and the same plus is giving precedence to leading of S. So as a result, we are getting here conflicts in the relation, which you cannot have in the precedence relation table. There has to be always a unique relation between two terminals. So we discard this table, we discard leading trailing, and then we find the reason is mainly because the grammar is ambiguous. You can start with any rule. We need to convert this first ambiguous grammar into unambiguous if we want to use it in the parsing. Okay, for operator precedence grammar, we need to consider the precedence of operators and associate to it as well. So we rewrite this grammar as S goes to S plus T or T, T goes to T star F, or F goes to D. Now for this unambiguous grammar, we are going to construct the leading and trailing. So we know leading of S is plus and leading of T. Leading of T is star and leading of F. And leading of F is D. So let's do that. As leading of T is leading of F and leading of F is D, we will get here leading of T also as D. Leading of S is leading of T, so we get here star and D as well. Similarly, for trailing of S is plus, trailing of T is star, and trailing of F is D. So we get here plus, star, and D. Now, for this rule, if you observe, trailing of S is trailing of T, and trailing of T is trailing of F. So because trailing of F is D, we have to get here D as well. And trailing of S is trailing of T, so we get here star and D. Okay, so leading and trailing is ready. Now let's prepare precedence relation table. Let's revise rules for this precedence relation table. We're finding relation between two terminals. So when we find two terminals together, the relation between two terminals is dot equal to. Two terminals separated by non-terminal, relation is dot equal to between these two terminals. Now in this grammar, which is modified one, we don't have anywhere two terminals together or two terminals separated by non-terminal. So these two rules are not required right now. Now if we have a combination, the terminal non-terminal, then in that case the terminal gives precedence to leading of non-terminal. So in this case we will find the plus is giving precedence to leading of T. Leading of T is star and D. So here plus giving precedence to star and D. Then next, the star is giving precedence to leading of F. Leading of F is D here. So star giving precedence to leading of F, that is D. Okay, the next rule is a non-terminal and terminal combination. So non-terminal terminal combination, in this case terminal gives precedence to trailing of non-terminal. So we have to look for those combinations. So plus entity and non-terminal terminal. So plus giving precedence to trailing of S. Trailing of S is plus, star and D. So plus is a column wala plus. There's a column entries now. So it giving precedence to trailing of S, that is plus, star and D. So this says that star has a higher precedence over plus. This says if there are two plus operators consecutive, then left wala plus gets the priority because associativity of plus is LR. So left has a more priority. Dot indicates a precedence here. Now next what we have is star giving precedence to trailing of T. Trailing of T is star and D. So star and D. Done. Now let's use the rules of dollar. Now for dollar the rules are leading of dollar, the row wise dollar is giving precedence to leading of starting non-terminal S, that is leading of S is plus, star and D. So plus, star and D. Dollar always has the lowest precedence, gives precedence to others. Similarly, column wala dollar is giving precedence to trailing of S, that is again same, plus star and D. So this dollar gives precedence to plus star and D. Okay, so it means this is in this case what remains here is this error, and for parsing we know dollar dollar is success, so we get this as success. Okay, so this is not error. Okay, so our table is ready now. Now using this precedence relation table, we have to construct the graph, using which we will construct the precedence function table. Path to G plus and F dollar. So F plus to G plus to F dollar. So path is 1 and 2. So this number is 2. Whereas for G plus, the path is directly only we can go to F dollar. So path is length is only 1. From F star we can go to G star. From G star we can go to F plus we can go to G plus, and then we can go to F dollar. So that path is 1, 2, 3, 4. So here we get number 4. For G star, we can go to F plus, G plus, and then F dollar. So this path is 1, 2, 3. So this number is 3. For FD, we can go to FD to G star to F plus to G plus to F dollar. So this path is 1, 2, 3, 4. From GD, we can go to F star, then F star to G star to F plus to G plus, and G plus to F dollar. So for this path is 1, 2, 3, 4, 5 is the length. So you'll get number 5. For dollar, there is no outgoing edge, so length of this path from F dollar is 0, G dollar is also 0. So that's the precedence function table for this problem.